So I would like someone to try to throw out the constraints that they saw here. Vinny, okay, so you have $60 to spend. We gotta stay up. Can we spend all 60? Yeah, but we have to spend 60 or less. So this is gonna be my symbol. How am I getting there?
With the money, with the
2 large bottles of sparkling water.
Well, 2 large bottles of sparkling water. Okay, so that's $4.98.
A pair of dishes.
And then what else am I spending money on?
A pair of dishes. That are $5.29 a pound.
$5.29 a pound. So this is a constraint that meets my situation. I gotta buy those 2 bottles of sparkling water for $4.98 total, plus $5.29 a pound. It depends on how many pounds we spend. The most I can spend is 60. Can I spend less than $60?
Yes.
Yeah. So, how many theoretical answers are there to this?
Anything less than 60.
Yeah, like.
I'm
Less
guessing
than or equal
about
to 60.
60 quadrillion billion.
Okay, a lot. Theoretically infinite answers. So that's why we need to solve this. We need to do something that shows us all these answers. Because what I'm guessing some of us might have done, which is where we're at, is we get right here, and it asks us for some values that work. So who's got some values that worked? What's a value that worked for pounds to purchase? Yeah, okay. 1 pound, that works. We're under $60 there. Cam?
10.
10 pounds works. Vinny?
10.4 pounds.
10.4 pounds does work.
It works. 10.1 pounds.
10.1 pounds, okay.
5 pounds.
5 pounds. So, we're noticing there's lots of answers that work to stay under budget. So,
Something under.
here's how we're going to do this. We're going to take our original constraint. The $5.29 per pound plus the $4.98 for drinks needs to stay less than or equal to our 60. We can solve this just like an equation. Right? So I'm going to subtract $4.98 from both sides. And what this is saying is, it's $5.29 a pound. That has to stay under. I know I'm buying those 2 bottles for $4.98 each, which I don't know why I did that in the calculator. That means I have $55.02 I can spend on the prepared dishes, right?
You just gotta divide.
So if I divide that by $5.29, that means in order to stay at or below budget, X needs to be less than or equal to 10.4 pounds. So anything. Although, like negative pounds mathematically works, but it doesn't make sense. Like you're going to show.
Give them a prepared dish.
Yeah. So you could say that it has to be greater than or equal to 0. X might have to be greater than or equal to 0. Just contextually, that's what makes sense. All right, y'all. Eyes on the board. Let's talk about Han's gas situation, okay? So Han has gas, but we don't know how much gas he has. Here's what we do know, though. He is going to burn through 0.4 gallons of gas each hour driving. And that amount, it has to be less than or equal to the 5 gallons that could be in his mower. So this would be our constraint, right? We know he has gas. We just don't know how much gas he has, right? Then I'm going to divide by 0.4.
That's what I did.
And the hours he can mow are 12 and a half hours or less. Now, one way I like to see this is 10, 11, 12. If I had a number line, 13. Does 12 and a half work? Yep, so solid on the number line, but everything left. Although 0 works with my inequality, you can't mow the lawn 0 hours. All right? You can't. Well, less than 0 hours, actually. You could do 0 hours. That works. But less, you can't go negative hours on it, right? We're going to do this one a little different than what's here, okay? So we're going to use what you learned last year and what I'm going to call the Mr. Mac method, even though it's not my method, but it's how you... So both Andre and Priya here, they solved an inequality by making it an equal sign, all right? I want you, for the Mr. Mac method, I would say is you put in the symbol and keep the symbol all the way through, okay? That'd be the Mr. Mac method. Last year, you would substitute 0 in for x and see which way your symbol would have to go at the end to make it true. I want you to look through both of these and make sense of both ways to decide on symbol. So you guys need to decide on symbol down here. because notice these are equal signs. We do solve an inequality like it's an equation. If you do the same thing to both sides, you get an equivalent inequality. So I want you to try those two methods. We'll call it the Mr. Mac method for the lack of a better term. Okay, where we just keep the sign through. And then on the left side, look at substituting 0 to get your symbol at the end and see what you get. So I want a symbol for both of these. So like, we know that there's an X and a 3. I want you to use both strategies to get the correct symbol in there. All right, so let's test out the 0 method. We'll throw a 0 up here. And if we throw a 0 in there, we get 3 equals 18. So which way would I have to go to make that true?
The smaller way.
Less than, right?
Mm-hmm.
So does 0 work? If I go less than, can X be 0 then?
Yeah.
Yes. Now, over here, it just stayed less than. Now, let's say I'm gonna circle Andre's method here, and I'm gonna keep this symbol in it. Negative 15 is less than negative 5x. So I just want to look right there. I'm gonna pop this out. Now, here, if we're gonna do my method, what would we have to do when I divide both sides by negative 5? What do I have to do to my symbol? I'd have to flip it, right? So instead of open toward X, I'd have to go close toward X. And I'm going to show you why. Notice they're all the same.
Wait, that's the exact.
No, because I moved X to the left.
Oh, yeah.
Check it out. Open to X, close to X. So here's the reason why this works. And this is, I like the way I do it. Maybe that's why I call it Mr. Mac method. But let's make sense of why it works. So then then we're not memorizing anything. So we're going to start with this really easy inequality. You ready for this? 1, Brendan, is less than 2. Everybody good? Now, if I were to, let's just multiply it all by 2. And we get 2 is less than 4. Is that true still?
Yeah.
Let's subtract them both by 3. Negative 1 is less than 1. Still true? Because all these, they're both changing in that relationship of big to small together. Now watch what happens when I multiply both of these by negative 4. I get a 4 and a negative 4. Which one of these is smaller?
1 times negative.
So if I were to multiply those by a negative number or divide by a negative number, it flips the relationship. And here's why. Take a look at my hands. This is 0 on a number line. These are negatives. These are positives. When you make things their opposite, what happens to the positives? What happens? They switch. So like big things become small things become big things. So the relationship switches is the reason you need to flip the symbol. Whereas if we're just straight adding, straight subtracting, they're all moving together. But as soon as we throw that negative on there and something becomes its opposite, it all changes to its opposite. Okay. So that's why if we multiply or divide by negative, we do flip the symbol, because it changes the relationship between big and small when we go to opposites. No other operations do that. Add, subtract, multiply positives, divide positives. That relationship changes together. All right? I'm going to split this up among groups. Group table 1 up here. You guys are going to do problem 1 and 2. Table 2 and 3. That's this table and that table. You're going to do problems 2 and 3. Everybody else, you're going to do 3 and 4. All right, so everybody's doing 2 of them. If you finish up, do more. If you finish up before we get back together. Let's run through these. I'm going to look at the first one. 1/5 p is greater than negative 10. So to undo this 1/5, I'm going to multiply both sides by 5. And that's going to leave me with p is greater than negative 50. So a lot of people, not a lot of people, some people will flip this symbol because they see this negative. But am I multiplying by negative or am I multiplying by a positive?
Positive.
Yeah, everything's 5 times more. So something small is 5 times smaller, something big is 5 times bigger. It doesn't change the relationship between big and small. If we test 0, it started as 0 is greater than negative 10. So 0 compared to negative 50 is still greater. All right, let's look at the second one. In the second one, when I did my algebra in the other classes, I did it different when I solved this one. The first thing I did here is I divide everything by 4. Anybody else do that?
No, actually, I just did.
That gives me...
4x plus 28 equals 8x plus 30.
So if I divide by 4, check it. The 4s are gone.
Yeah, just
I'm going to subtract x,
see if we got the same.
subtract 8, So x is greater than or equal to -1. Now, one thing
Oh, that's what I got.
I've heard some students say, Mr. Mack, you flipped the sign.
Then I just went with 0.
But look at open toward x, open toward x. So did I actually flip the sign?
Then I just went with 0. And then if you plug in 0.
Yeah, you could test 0.
Then it works.
0 would be 28 is less than 32.
Yeah.
So 0 works here.
So you know.
0 would have to be here because it has to be greater than or equal to -1. So I didn't actually flip the sign, but when I put my variable on the left, I needed to keep my same sign. Okay. So it looks flipped, but it kind of isn't. All right, third one. -9n is less than 36. I'm going to divide both sides by -9. Because I divide by negative, I need to flip my symbol. If you did the 0 thing, 0 is less than 36 is true, right? So if 0 works, here for 0 to work, 0 would need to be bigger than -4.
Wait, so if you divide by a positive, it doesn't switch it?
Correct, because if you divide something by a positive number, they're both that much smaller. It doesn't change the relationship between big and small. The multiplier divided the negative does change it. Yeah. All right, one more. Uno más. This one took a little more algebra, so I'm going to write it over here where I have a little more room. The first thing I chose to do here is multiply everything by, I'm going to divide by everything by -2, which is multiplying by -1/2. So that'd give me -c over 6. I multiplied by negative, so I flip it, and then I got c minus 7 over here. Oh, this is a double flip. I'm going to multiply both sides by -6. Flip it again. -6c plus 42. Then I'm going to add 6c to both sides. That's 7c is less than 42, which means that c is less than 6. There's a couple ways to go about that. Another thing, if I were to do this again, actually, here's what I might do if I were to do this again. I might distribute my 2 first. Yep, this is what I do. Then multiply everything by 3. Then this is definitely what I would do if I did it again. I guess this is what I'm doing as I do it again. Either way, c is less than 6. And you could test 0. Awesome. So big picture. Big picture. We can solve inequalities just like we solve equations. And to make sure our sign is right, we can use our properties of carrying our sign down and flipping it if we encounter a multiplier divided by negative. Or we can still test our 0 if we want.
So crazy.